This is a very typical exam style question. The size of the human population n can be modeled using the equation n is equal to n0 e to the power of RT, where n0 is the population in 2006, t is the time in years since 2006, and R is the annual rate of increase in the population. Part 1. In 2006, the population of a certain country was approximately 61 million, with the annual rate of increase of 1.6%. Assuming this growth remains constant, what would the population be in 2020, i.e., that is after 14 years? So we're going to start off with the equation that was given in the question. So n is equal to n0 e to the power of RT. So we replace n0 with 61 million. So that was given here in the question. The population of the country is approximately 61 million. So that the 0 then is now gone, okay? So n0 we replace with 61 million. The e just stays as it is. The R stands for the rate. So the annual rate of increase is 1.6%. So that can be written as a decimal as 0.016. Just be careful with your decimal places. And then the t, the time, is 14. So 14 years. Or you could have 1.6 with a percentage symbol instead if you don't want a decimal, or if you're a bit unsure with your decimal places. But just make sure that you don't use 1.6. It has to be 1.6 with a percentage symbol. So e to the power of 0.016 times 14 gives us 1.25107. I've just rounded to 5 decimal places here. That's enough. I wouldn't round any smaller than that, or you'll get an error in your answer. And then into the calculator, you get 76,315,270. Therefore, the population in 2020 will be 76.3 million. So it's important to end with a sentence, an English sentence. So put it back into context. Part 2. In 2006, the population of another country was approximately 5.1 million, with the annual rate of increase of 0.43%. Assuming this growth rate remains constant, how long would it take for this country's population to double in size? Double is really, really, really important here. We're going to use that in the question. So double is extremely important here. So again, we start off with the formula or the equation that was given in the question. So n is equal to n0 e to the power of RT. We're going to replace n with 2 times n0. So we were told that n0 is the population in 2006. We're interested in when it doubles. So it's going to be n0 times 2. For the population to double in size, we multiply by 2. That's really, really important to this question. So n0 is 5.1. We were told it was 5.1 million. You can keep it as 5.1 so long as you keep the right hand side the same, so 5.1 as well. As in, you don't need to have 5,100,000. It's just a bit tidier to use the decimals. But just make sure that you've got the same on both sides. So you couldn't have 5.1 on the left and then 5,100,000 on the right. You have to either have decimals or have the long numbers. So we have 2 times 5.1 because it's doubling. We're interested in when it's doubling. And then we replace the or with 0.0043. So the annual rate of increase was 0.43%. But again, as before, you could use the percentage, but just make sure that it's exactly written as so. So 0.43 with a percentage symbol stuck on. If you forget the percentage symbol, it'll be completely wrong. So you choose which method you want. So as a decimal, 0.0043 or else 0.43%. It's up to you. So 2 times 5.1 is 10.2. So we're going to divide both sides by 5.1 to try and isolate the e. And 10.2 divided by 5.1 is 2. So we have 2 equals e to the power of 0.0043t. Now up here, I've just put the e on the left because the t is what we're trying to find. We're trying to solve for t. Remember that e is not a variable, it's a number. So that's really, really important. You're not trying to solve for e, it's a number. You're trying to solve for t. So it's really important that you don't mix those two up and think you've got two variables here. You've only one variable now, it's t. So I just put the term that has a variable on the left-hand side, but you can keep it on the right-hand side if you want. So that's equal to 2. Okay, so just some rough work. There's a couple of ways you can work out this question. I'm going to show you 2 ways now. So this is the first way. So we want to write 2 as a base of e. So if we rewrite 2 as a base of e, then we can just cancel the e's on both sides and we can equate the powers and solve for t. So e to the power of what gives us 2? We need to figure out what that is. E to the power of what gives us 2? So log base e2 is going to be 0.69315. I've just rounded to 5 decimal places. Don't round any shorter than that or you'll have an error in your rounding, a rounding error at the end. And just to note that when you have to input this into the calculator, you'll be expected to put in a power for e. So just put it to the power of 1. E on its own is e to the power of 1. So e to the power of 0.69315 is equal to 2. So now we can replace the 2 with e to the power of 0.69315. And now we can equate, our e's are the same on both sides, our bases are the same. So we can cancel out the e's and we can equate our powers. So we have 0.0043t is equal to 0.69315. Now solving for t, so dividing both sides by 0.0043 gets the t on its own. So we get 161.19767, which rounds off to 161.2 years. So another way to work out this question, so the steps are all the same up as far as this part here. So we have e to the power of 0.0043t is equal to 2. So we can rewrite that as log base e2 equals 0.0043t. So it's our scorpion tail method in reverse. So we know e, if we follow our scorpion tail method, we have e to the power of 0.0043 is equal to 2. So it's just our scorpion tail in reverse. So we're just rewriting it. And log base e can be rewritten as ln. So it's just another way to write log base e, so the natural log. So they just mean the exact same thing. So ln2 is equal to 0.0043t. So I've just swapped them around so that the variable, the t, is on the left-hand side. Now remember, L and N are not variables, okay? They're a number. ln2 is a number. So don't mix it up and think there's 3 variables here now. The t is the only variable, the only unknown value. So we get t is equal to ln2, so the natural log of 2 over 0.0043, which again gives 161.197. Therefore, it will take 161.2 years for the population to double in size.